and start from current slide. Now, I think what I'll do is wait to go through schedule and everything else at the end of, how we're going to wrap up the term. Let me mark the roll first, and I'm not here today. Okay, Curry's here, and Takesha's. Okay. So, if either of you have to leave early, let me know a few minutes before you do so I can cover that. And if anyone else comes in, then everybody will get to hear it, and I won't have to say it so many times and bore y'all to death because you would have heard it every time. All right. Any questions on anything we've done so far? Anything else? One, remind me to, when I do the thing at the end, to talk about student course evaluations. They have opened them up. Now they're there, so remind me to include that. They just have gotten them open either late last week or early this week, which is awfully late. Okay, if there are no questions, we're on in Chapter 4, Higher Order Differential Equations, 4.4, Undetermined Coefficients, and we got down to, on page 146, we did example 4, and we're in, there was a little bit of verbiage leading up to that. The difference in the procedures used in examples 1 through 3 and that in 4 suggests that we consider two cases. Now, if you remember that, 1, 2, and 3 just went pretty well. Example 4, the driving function, the g of x, happened to be one of the solutions to the complementary differential equation, the one that's the homogeneous case. So here are the two cases we deal with. No function in the assumed particular solution is a solution of the associated homogeneous. That's like questions 1 through 3. If that's the case, we're in good shape. Okay? Now, they list a table, and since y'all don't have the text, let me go on and put these down. And these will take a while to write, so let's get going on them. Okay. First column here will be your g of x. If I can get the pen to come up. It's not coming up. There it goes. I'm sorry. Here is your possibilities for g of x. And these are the potential forms of the particular solution. Potential forms. Okay? All right. If g is a constant, okay, they put 1, but any constant, then the form for y sub p will be a. Okay? A constant. Okay? Pretty straightforward. If it's a linear, g of x is a linear function, like 5x plus 7, any linear function, a linear polynomial, okay, then your y sub p should be ax plus b, okay, where you've got to determine your coefficients, okay. If your g of x is quadratic, I'm not going to put down the thing, I'm just going to put quadratic. I can't write. A quadratic polynomial, okay, then this is a quadratic polynomial. ax squared plus bx plus c. Now maybe in this case I should write it down. Even if this quadratic polynomial is of the form x squared, if that's all there is, you still put all three. If it's 2x squared minus 4 or minus 5, okay, or something like that, you still put down all three. Don't just mimic what g is, put the full extent of a quadratic function, okay, for your y of p. Okay, if it's a cubic function, I think you get the picture here. cubic polynomial, what do you think it was going to be? AX cubed, second, plus BX squared, plus CX, plus, they don't like to put D, they put E. Okay, I think I know why, but whatever. Now, this is, even if this cubic polynomial is only x cubed, or 3x cubed minus 1, or anything else, even if it doesn't have all four terms, put all four terms down as your y sub p. Okay? Sine of 4x, or I'll just put it like they do. Any sine function. What do you think the y sub p will be? A sine 4x plus b cosine 4x. Okay? Notice the 4x carries over. Okay? That doesn't change. But you need both sines and cosines, and you need those coefficients. Similarly, what you reckon it is for cosine 7x? A cosine 7x. Okay, you can do it that way. Plus b sine 7x, or any order, it doesn't matter which one you put first. Okay, absolutely. All right, what if you have something that looks like this? 9x minus 2 e to the 5x. If that is your g of x, what does your y sub p look like? ax plus b. Second?
Plus a.
Okay. Okay, now they put it as a times e to the 5x. And I'm with you. I would have said that needs to be a plus there. Let me make sure they haven't gotten off here. Okay. Okay, so it's linear combinations, but it needs to be in that same form. So I believe they're right here that that is a times there. Okay, now let's do a different one. X squared e to the, and they happened to keep it 5x, it didn't matter. Okay, there's nothing special about 5x there. What you reckon this has to be? ax squared, say again? Plus bx plus c e to the 5x. You have to include all the possibilities there. Okay? Now, let's flip something around. I'm going to do a g of x over here and a y sub p here. Okay? What if you had something like e to the, they've gone down to 3x, it doesn't matter, times sine of, I guess their favorite is still 4x, so it doesn't matter. Okay? What would be the form of y sub p? Okay. A sine 4x plus b cosine 4x times e to the 3x. Okay, very good. All right, Taylor. And by the way, to let y'all know how special you are, yesterday I had hoped to have most of my 4 hours in the office grading papers. Well, I had 2 finals to make up, a student come by for tutoring, another student come by for registration, and faculty member come by to report on the hearing, planning hearing, and go over stuff with that. So I wound up grading 0 papers in my 4 hours in there. I also ate lunch, but 0. I got none graded. So I went home last night and got this class graded. Y'all are so special, but I got 0 done on any other class. So they're going to have every right to be somewhat angry today. So sorry about that, but at least I got yours graded. Okay. Now, we're doing, if you have a book, it's on page 146, bottom of the page. These are the various forms of g of x and what form your particular solutions would need to be to match that. What if you have a 5x squared sine? They love 4x. There's nothing special about it. What would that possibility be?
X squared plus bx plus c.
Okay. Ax squared plus bx plus c times, what do you say, sine? 4x. Okay, nope. Need new ones. Yeah. You need ex squared plus fx plus g times cosine 4x. So you have to have the full range of polynomials, but that the coefficient functions are different for the sine and the cosine. Okay? Now, how about this one? I don't have room for it, so I'm going to move it down here as much as possible. X e to the 3x cosine 4x. Okay, if that's your g of x, what you reckon your y sub p is going to have to be? Any ideas? Okay. Yeah, I'm going to put the e to the 3x out front. They don't, but I see no reason not to. E to the 3x times, okay, continue. Ax plus b times sine of 4x, or it doesn't matter which one you do first. They did cosine first, but it doesn't matter. Next, plus cx plus e cosine 4x. They did the cosine first and the sine second. But here's the deal, and it's a little bizarre to me, but it's true. When you have a sine or a cosine alone, you need the constants in front. When you have, the funny thing is they didn't do e to the x by itself, did they? Yes, they did. I missed it. Yeah. I did miss it. I left it out. Sorry about that. It's their number 7, right after cosine 4x. I should have put this one. I'll put it over here. E to the, they use 5x, whatever they want to use there. That would be a e to the 5x. Okay, I left that one off. Okay. Now, what I was going to say, when you have, we understand the polynomials. I hope you do. Okay. When you have sine or cosine, then you put a constant in front of both the sine and the cosine. Okay? When you have an e to the x, you put a constant, or e to the whatever x, you put a constant in front of that same e to the whatever x. But then when you start having combinations of them, you focus all your constants in the polynomial without a separate constant here. Well, that makes sense. If you think about it, if you had a separate constant here or here, then you just incorporate it here, multiply it by there, and you still have it. So you don't need that additional constant. And since you have this polynomial term in front of sine and cosine, you don't need a separate constant there either, because they get incorporated here. And because you have the a and the b here, you don't need a constant here, because that can be incorporated in the a and the b and the c and the e, because it's multiplied by all that. And you don't need it for sine and cosine, because that's the same thing. So the polynomial absorbs all those constants, okay? And you don't need a separate constant in front. You put it there, you just have more work to do, you find out it really doesn't matter, okay? That's just a note. It seems like they left it off, but really they didn't. All right, so let's do example 5. Now this is still for case 1. No function in the assumed particular solution is a solution of the associated homogeneous differential equation. In other words, a part of the C1, complementary solution. Okay? So let's do example 5. Any questions before I take this off? Okay. Example 5. Also a case 1. Determine the form of the particular solution for y double prime minus 8y prime. Boy, I sounded southern on that one, didn't I? Plus 25y is equal to 5x cubed e to the 3 negative x, sorry about that, minus 7 e to the minus x. Okay. Now, what I think Curry and I were both thinking of before, now we do have superposition here. When they're multiplied, you don't split them out in superposition. When they're added, you do. Okay? So, all it's asking for, the form of the particular solution. What would be your guess? Without doing the homogeneous part, without doing the complementary part, just do y sub p. Okay, ax cubed plus bx squared plus c. Second? I'm sorry. Oh, I'm sorry. C, yeah. I was thinking quadratic. This is cubic. Okay, you're absolutely right. Cx plus e, they don't like to use d. E to the minus x plus a e to the minus x. That, well, not a, f. Okay, I don't know what you said, but I put a down. Needs to be a different constant. It's not the same as that a there. Okay. All right. So the particular solution. Whoa. Well, they do the complementary. The yp is ax cubed plus bx plus c, bx squared plus cx times e. Oh my. Okay, I'm sorry. For some reason I was thinking those are two different exponentials. You don't need this. I was thinking one of those was a plus and one was a minus. They're not. I wrote them as if they were crazy. Okay, you don't need a separate thing here because you see, you could have written this as 5x cubed minus 7 times e to the minus x. So you only need the polynomial there. I was thinking those were different exponentials, and if they do, then yeah, you need another term. Okay? But this one does not have that. These are both e to the minus x. So that's all we need for that one. Okay? Now. Okay? Now, can you say, oh, I know that's the case. No, you really have to do that complementary solution. Why? Because this has an e to the minus x. What if your m from up there had turned out being a minus 1? Then you can't do it this way. You have to do something else. So we do need to do the complementary solution. What would that be? Okay, it's going to be a quadratic. It's going to be m squared minus 8m plus 25, which is no way to factor. So that's going to be m is equal to 8 plus or minus square root of 64 100 over 2. And what else can you tell me about it? Just looking at that. Sines and cosines, absolutely. And this one has no sines and cosines, so it won't be. Let's take it on because this is sort of a fun one. What would that be? 8 plus or minus the square root of negative 36 over 2, which would be 8 plus or minus 6i over 2, which would be 4 plus or minus 3i. So what would be your complementary solution? Y sub c. You remember? C1. A little louder. Yes, and it doesn't matter where you put it, but e to the 4x. Well, yeah, it does matter. Because to keep from having to write it a second time, I want it to have it in front. And I'm lazy enough to do that. E to the 4x times C1 sine 3x plus C2 cosine 3x. So I almost botched it there because I thought, nah, that one's not going to have a minus 1 because it's not going to factor as a minus 1. Guess what? You have e to the 4x. That could have been a e to the minus x. It isn't. Okay? If that had turned out being a minus 1 in front, then you would have had problems up here. Okay? Potentially anyway. So we're okay. All right. That done. Let's move to B. And all right, to erase. And by the way, Taylor, right? Yeah. If you do have to leave early today, let me know a few minutes ahead so I can go through everything that we have to do before the end of the term. Okay. And where I'll be and that kind of stuff. So let's do the B part of example 5. Y double prime plus 4y is equal to x cosine x. Okay? Let's go on and do it the way we normally would. What would you do first? Okay? And what do you notice about that? Of course, you set it equal to 0. It's going to be what? Not just irrational, complex. Right? Okay? So what will it be? Plus or minus 2i, you got it. Okay? So what would be your complementary solution?
C1 sine 2.
So, yeah, okay, C1
Sine 2x.
times what?
Sine of 2x.
Okay, sine of 2, I can't hear.
Plus C2 cosine
Okay, perfect. And the reason we don't have an E term here is you don't have a real part of your complex number. That's a pure imaginary. So your real part is 0 and e to the 0 is 1. So yeah, there's a 1 up there. You just don't see it. Okay. So there's your complementary solution. What you reckon is going to be your particular solution?
AX plus B
AX plus B
sine X.
sine X
Plus CX plus D.
CX plus E cosine X. Now, notice we have sines and cosines in both places, but they're different arguments. So you're okay. Those are different functions. So you don't need to adjust for that at all. So your general solution would then be all those put together, and I'm not about to do that. Okay. And they put the cosine first. It doesn't matter. Okay. All right. Now, if g of x consists of a sum, say, of m terms of the kind listed in the table that we did before, okay, then, as in example 3, which was back a ways, the assumption of a particular solution y consists of the sum of the trial forms yp1, yp2, yp3, every one of those, and then you just add them together. Okay? Here is another way to say that. Is this worth writing? Yeah. The form of y sub p is a linear combination of all linearly independent functions, I'm abbreviating like crazy, that are generated okay, by the repeated differentiations of g of x. Differentiations. I think I spelled it right. Differentiations of g of x. Okay. Now, when they're multiplied together, you just keep them multiplied together, but you expand them whatever you need. If they're added or subtracted, the function g of x, then you do linear combinations of those. Now, it's not the pure linear combination we were doing before with the complementary solution, because notice there are no constants. Okay? It's not a C1, y sub P1 plus C. You don't do that. It's just add them together. Because you see, you already got your constants in there, right? Those y sub P's have the constants. You figure out what those constants are and then just add those together. All right, so let's do example 6. All right. Y double prime minus 9y prime plus 14y is equal to 3x squared minus 5 sine 2x plus 8x e to the 6x. All right. Now, let's go on and do what we'd normally do. What would be your first step? Anybody? Help me. I'm drowning here.
X squared
m squared minus 9m, what'd you say, plus 14 equal 0. What do you get out of that? M minus 7 times m minus 2. Is that what you said? Right? So what's your m's? 7, 2. Okay. So what would be your complementary solution?
C1 equals 2x plus C2 equals 7x.
Okay. Now, what I do automatically, flash up to your g's here, and this is a combination of several g's. There is an e up there, but it's not either 2x or 7x, it's 6x. So we don't need to worry about case 2, which we haven't gotten to yet, but we did see an example that warned us about that. So what do we do about your particular solutions?
Ax squared plus bx plus c.
Okay. We're going to call this, let's call this g1 of x plus g2 of x plus g3 of x. Okay? And for g1, what you have, you said? The yp1 is, okay, sorry, ax squared plus bx plus c. Okay? There's your yp1. Done. Okay? yp2, what would it be?
A sine 2x plus better.
Second?
Wouldn't it be a e?
I can't hear.
Wouldn't you make it a e?
Oh, yeah, I'm sorry. All right, wait just a second. Let me get my pen back. And let me get, and by the way, I guess I will mark Taylor here since she came in. And we'll mark Rod here since he came in. Okay? Now, I've been telling the others, and I'll say it again. Before anyone has to leave, give me a few minutes. Let me know. Give me a few minutes, and I need to. Goodness, it's gotten all screwed up. Okay. Oh, good deal. Thanks. All right. All right. And here's your test 2. Give me a few minutes so I can go over how we're going to wrap up the term, where I'm going to be, when I'm going to be there, what you need to do, all that kind of stuff. Okay. So I want to wait till everybody gets here so I don't say it 4 or 5 more times, you know. Don't have that many more students. Okay, what's your YP2? What we're doing is example 6, bottom of page 147. Is what?
E sine 2x plus.
Okay. E sine 2x
Plus
f cosine 2x. Okay. Okay there. It's funny when it's a constant polynomial in front, it's no different than if it was 1. Okay. That's just a constant. So we're fine there. How about our YP3?
ax plus b, or not.
AX.
It'd be different.
Oh, you get me going on it every time, right? Okay. All right.
Gx plus
Okay. GX plus
h,
H
e to the 6.
e to the 6x. Okay? So then once you figure out what all those things are, those constants and stuff, then you go back and put them together, and that will be your combination there. So let's see what we got. AX squared plus BX plus C plus E. They put cosine first, I don't care. Sine 2x plus F cosine 2x plus GX plus H in parentheses times 6 e to the 6x. Perfect. And then combine that with your complementary solution. Neither of those e's are 6x. They're 2 and 7, so you're fine. So now let's consider case 2. Case 1 was when none of the g of x's paired up with your complementary solution. Case 2 is when they do. Okay? So let's erase this. All right. A function in the assumed particular solution is also a solution of the associated homogeneous differential equation, in other words, part of the complementary solution. So this one's similar to example 4, which we already did. So here is example 7. Y double prime minus 2y prime plus y is equal to e to the x. Okay? And what would you do first? M squared minus 2m plus 1 equal 0. What would that give you? M minus 1 times m minus 1 equals 0. So what you got? M equal 1. But it's a double root. How did we handle those in the complementary, the homogeneous case? How did we do that? YC is equal to what? C1e to the x plus, let's do C2x e to the x, right? Okay. Doesn't matter, but usually you put the constant in front. Okay? Now what do you notice? That's the same as your general solution, whatever you call the g of x. I guess because it's general, I call it g, but I don't know. Okay, here's Monica. Okay. I need to get you this. Oh. Yeah, you can, but I grade what I get. So whatever comes across, that's what I have to grade.
Okay, I got it on my computer. I just didn't know if if I could print it out somewhere here.
You can. You'll have to find one of the labs that will allow you to print, which I think there are a few around. But or you can email. What's that?
Your school ID to get in the lab.
I can't hear you.
Do you have to have your school ID to get in the lab? Because I don't have one.
You don't. I don't think so. Not most of the labs. The library, you probably would need it to use theirs. Has anyone printed in one of the computer labs?
I know Birmingham campus has one. I'm not sure about this one.
Yeah. I know there are a couple of, let's see. I know there's several labs with computers in them, and some of those have printers in them, but whether the printers talk to the computers or whether the printers have any paper or whether the printers work, I don't know that one. So if you'd rather print it out, the trouble is I have such little time between. I can, if you want to, take it down to my office and let you print it on my computer.
Okay, fine.
Yeah, okay. But you can email it to me too, either one you want to. But this has happened once this term already. Someone emailed me a paper, and on their title they had center justified, and they forgot to take that off, so their entire paper is center justified, and that's not very standard. Instead of left justified, it was center justified, so they lost a point or two on that one. So that's why I say, if you're very confident in how it's going to email, you can do it, but be attentive. All right, here we have our g of x is of the same form as your complementary solution. Well, so what would you guess a particular solution that will work here? I'll tell you now, e to the x will not. So what would be your next guess? x e to the x. But guess what? That won't either, because that's a part of your particular solution. So give me another guess. Keep going. X squared e to the x. That would be the particular solution to use. Oh, ax squared e to the x. You need the constant in there and go with it. Okay? Then once you figure out what the a is, plug it in down here. Add it to that one. Okay? And sure enough, that's what they use. And surprisingly, this time, they actually go back and figure out what that is. So what is your particular solution? Let's remind ourselves how to do that. What would you do to figure out what the a is? Say again? Yeah. So yp prime would be, ooh boy, 2ax e to the x plus ax squared e to the x. Okay? I'm going to simplify that slightly to make it a e to the x times 2x e to the x plus 1. I don't know if that's helpful or not, but I did it. No, plus x. Sorry. Let me see if I did that right now. Yeah. Yeah. No, I didn't. Plus x squared. Okay. Man. So now should I take out an x? I think not, but I'm going to do it anyway. Ax e to the x. So let me rewrite it. Okay. See if I can get my head on right today. That's not a good probability that's going to happen, but let's try it. That would be ax e to the x times 2 plus x. Is that right now? I believe so. Right? All right. We still need to do a yp double prime, second derivative. And I don't know if the second form's any better than the first. I kind of think not. So maybe it'd be better to do this. A times 2x plus x squared e to the x. I think that would be the easiest form to do a derivative on. I don't know, but let's try that. What would be your derivative of that?
2a to the x.
Okay. I'm going to put the a out front, okay? And then what you got? What's the next part?
2 plus 2x.
A little louder, I can't hear.
2 plus 2x.
Okay, 2 plus 2x e to the x help me plus 2x plus x squared e to the x. All right. Now, I don't know if this is helpful or not, but I'm going to do it. Let's factor out keep the a that's out there, the e to the x, which is in both terms. And I think that's all we can do. Let's combine what's left, and you have 2 plus 4x. Is that right? Yeah. Plus x squared. All right. Now, this is what, okay, so let's write down our equation. A e to the x, I think I'm going to recombine. I'm wishy-washy on this one now. 2a e to the x plus 4x, 4a x e to the x plus a x squared e to the x. That's the first one. Minus 2 times your y prime. So it's going to be a minus 2, another 2. So minus 4ax e to the x minus 2x, ax squared e to the x plus ax squared e to the x. All right, and that's supposed to equal e to the x. All right, so obviously all these terms with the x squareds in them need to add to 0. Well, look at the first one. Ax squared e to the x plus ax squared e to the x. That's 2ax squared e to the x. That goes to 0. The 4ax e to the x minus 4ax e to the x, that goes to 0. Good so far, and now we have 2a is equal to 1. Okay, so therefore a is equal to, help me. Say again? Anybody? It's pretty easy. 1/2? Is that what I heard? Divide both sides by 2? All right. High-level calculus. Okay. So, we have our particular solution. And can I erase all this and just write it down? This will be 1/2 x squared e to the x. So I'm run out of room, so I'm going to erase all of this. Now let me, maybe before I do, let me make sure I got it right. A is equal to 1/2. Good for them. Okay. Okay. So I don't need these anymore. Okay. Got our particular solution. We have our, I don't need to erase all that. Our general solution now is y is equal to c1 e to the x plus c2 x e to the x plus 1/2 x squared e to the x. I don't need to erase all the other. There it is. And is that what they got? Well, I thought for sure they wrote it all out. And what was I thinking? I thought I saw that in here. So I didn't need to do all that. They just did the YP part. I'm sorry. I thought they put them all together, but it was only one more step. So what's the multiplication rule for case 2? If any y sub p, any one of them, contains that's y sub pi, contains terms that duplicate terms in the yc, the complementary solution, then that particular solution must be multiplied by x to the n, where n is the smallest positive integer that eliminates the duplication. And that's what we just saw. The complementary solution had an e to the x and an x e to the x, so we needed to take care of that. Since our general solution was also e to the x, we needed an x squared e to the x, and we got it. So let's do example 8. All right, to erase. So here's one. y double prime plus y is equal to 4x plus 10. Oh, plus 10 sine x. My eyes are not working well today. Plus 10 sine x, where y of pi is equal to 0, and y prime of pi, so this is an initial value problem, is equal to 2. Now, I kind of don't like calling initial because pi isn't what I think of where you start. But that's what they always call it, so we'll call it that. Okay. Does this look like it might be a well-posed problem? Say yeah. Okay. Okay. Where do we go first? Help me. Second? Okay, a little louder. I didn't hear. Probably said it right, I just don't hear well. M squared plus 1 equals 0. What does that give us? Second? Plus or minus I. Okay? So what does that tell us? Our y complementary will be C1 sine x plus C2 cosine x. All right. I can see problems because sure enough sine x is going to be one of your general solution, or whatever, g of x. So we're going to have to fiddle with that one some. All right. Now, you might ask yourself, no, let's not do that. When do you plug in, okay, your initial value, okay? Wait till the end. Don't plug it in at this point. Wait until you put them together, then you plug in. So back when we were doing homogeneous equations, yeah, you'd plug it in right now, but we're not doing homogeneous, we're doing non-homogeneous. So you tell me what y, if this is g1 of x and this is g2 of x, what's your yp1? ax, did I hear? Plus b. Very good. What's your y2 of yp2? ax sine x. Perfect. Okay? Okay, it's up my a. Goodness gracious. What do we put there? C. That's yes in Spanish. cx sine x plus e. No, I think you got to put the x with it, I believe. Cosine x. I think you do. Let me check. Yeah. Yeah, you put the x with both of them. Otherwise, you're going to wind up with duplication again. Okay. Now what? Help me. Second? Take a derivative. Okay. Now, let me think. I think we go on and put them together. I see no reason to keep them apart anymore. So let's put them together. This plus that. You know, that's not a very elegant way of doing it, but let's do. So what is your yp prime? Help me. A plus
C sin x plus
so okay, C sine x, is that what you said? Okay. Say again. Plus C x cosine x plus E cosine x minus E x cosine x. Sine x, I'm sorry, sine x. Okay. Okay. Now let's see. I don't think there's much I can simplify there, is there? No. Let's do yp double prime. What would that be? A little louder. C cosine x plus C cosine x, you said? Okay. Minus. Wait. I think that's just, yeah, you're right. Cx sine x. I was getting lost which term I was looking at. Okay. Minus sine x minus E sine x minus EX cosine x. Okay. Now, let's combine some like terms here. These two combine to be 2C cosine x. C's and cosines don't go well together. Minus Cx sine x minus 2E sine x minus EX cosine x. Okay. Now, let's plug that into our original. So we got 2C cosine x minus Cx sine x minus 2E sine x minus EX cosine x. There's your y double prime plus y, which is those things added together. So it'll be plus AX plus B plus CX sine x plus EX cosine x. And that's supposed to equal to 4x plus 10 sine x. All right, let's see what we got. All right, pretty easy, I think, to start with the linear term. And they only got one here and one there, so it's pretty obvious, I hope, what is A. Any guesses? These two have to equal each other, so A is equal to 4. Then you go to your constant terms. There's your constant term on the left. There aren't any constant terms on the right, so B is equal to 0. All right. Now, your sine x terms, okay? That would be this one. And I think that's all, isn't it? So we've got a minus 2e is equal to 10, don't we? So guess what e is? E is equal to negative 5. Now, I'm hoping the rest of them disappear. If they don't, we're in serious trouble. Minus EX cosine X plus EX cosine X, those go away. Whoa, we're in trouble. Okay. I'm kind of hoping I wrote it down wrong, but I don't think I did. All right, no, we're okay. We're okay, I think. These two do disappear. Cx, sine x, and C plus and minus that, those disappear. We got one more variable, and that's your cosine, 2c cosine x, and there aren't any here, so that means 2c is equal to 0, which of course means c is equal to 0. So, I think I'm going to need more room. So let me go up here and start erasing. Okay. I know I don't need that line anymore. Okay. And I'm pretty sure I don't need this line anymore. I think we've already substituted that in, so we're okay there. And I think we did it here too, so we're all right there. And I'm real tempted to say we could get rid of this line as well. Yeah. All we need are our constants, our particular solution, and our complementary solution. Okay. I'm hoping I won't need that. If I do, y'all have to reproduce it for me. Okay. That will be left to the student. Okay. So here's our general solution. Y is equal to C1 sine x plus C2 cosine x plus 4x plus minus 5x cosine x. I hope I got it right. Do y'all agree or not? You hope I do too. Okay, I see. All right. Now, this is the one we now plug in our initial, and you let me erase it, didn't you? You let me erase the first derivative. Why did you do that? Why? Well, we had to anyway. Okay. So it would have been helpful maybe to keep that, but we're okay. So now that we got all that done, we need to know what, it doesn't matter what order. Let's go on and plug in our pi. Okay. So y of pi is equal to what? What's sine of pi? 0. Okay. Cosine of pi? Okay, so that would be a minus C2 plus 4 pi minus 5 pi, well, that becomes a plus 5 pi, right? All right. And that's equal to 0. So that means that C2 is equal to 9 pi. Did I do that right? Agreed? Okay. Now let's do our y prime. Okay, we'll do it of x first. And what would that be? Anybody? Here's your y of x. We're trying to do y prime of x. What would that be? Help me. C1 cosine x. Okay, let's go on and plug in 9 pi, since we already said that's what C2 is. Sine x, right? Plus 4 minus 5 cosine x plus, second, 5x sine x. Okay, there's your y prime of x. Now, I think I can erase the bottom line now because I've already got all those in. So let's get rid of this line. I sure hope I have them all in. I think I do. Okay. So now let's do y prime of pi, our second condition. And that's equal to what? What's cosine of pi? So that's a -1, so that's negative C1. Sine of pi? 0, so that goes away. Plus 4. What's next? Plus 5. Next? 0. And this is equal to 2. So that means, I think, C1 is equal to 7. Is that right? All right. So now we can write down our general solution, and that's equal to, and you can put y of x if you want to. The C1 was 7 sine x plus C2 was 9 pi cosine x yeah, plus 4x, there it is. I knew I had it down here somewhere. Plus 4x minus 5x cosine x. That should be it. Let's see how they did. They start with the minus sign. Oh no, I'm sorry, that's the wrong line. Y is equal to 9 cosine x, 9 pi cosine x. They always like to start with cosine. Plus 7 sine x plus 4x minus 5x cosine x. They got it right. Good for them. Okay. Okay. Anyone need a bladder break? Just to stretch or anything else? Do? Okay. Let's take a quick break now. So I will delete it. Hearing none. All right. Let's move on to example 9. Yeah, we got screen now. Okay. Let's solve this differential equation. Y double prime minus 6y prime plus 9y is equal to 6x squared plus 2 minus 12 e to the 3x. Okay. Where would you begin? Anybody? Say again?
Quadratic.
Okay, and what would that be?
M squared.
M squared
Minus
minus
6m.
6m
Plus 9.
plus 9. Okay. Now, it's okay to call it quadratic. If that had been y to the cubed, it wouldn't have been a quadratic. I mean, the third derivative of y, it would have been a cubic. So it's technically your auxiliary equation. And most of the time, they have been quadratic for some reason. The book just, well, they're easiest to figure the zeros for. So what would you do next? I think I just said it. Set it equal to 0. What does that give you?
Minus 3.
M is equal to negative 3. Is that what you said? Oh, you said M minus 3. Okay, sorry. Okay, I couldn't hear what you said. Okay. You're right. M minus 3 times M minus 3 is equal to 0. So what's your solution?
Plus 3.
M is equal to 3, but it's a duplicate 3. Multiples. So again?
So it's I.
I can't hear.
So is it I? 3I?
No, that would be only if it was complex. What you do not, these are real solutions, M equal 3, okay? If that had been M squared plus 9 without the 6m in there, the minus 6m in there, then yeah, that would have been M plus 3i and M minus 3i. That would have been your i's there. This is a 3. So what is your complementary solution? Y sub c. And sometimes I like to do this just to remind myself. I get into such a rut of doing it, I forget why I'm doing it. Whenever you have constant coefficients here, right, then our assumption is y is equal to e to the mx. That's where that came from. That's where the m came from. When we took the derivatives of them, every time you increased another m. But everything else is the same. So what's your y sub c? C1 e to the 3x. No, that's where your 3 goes, the m. But what's the next one? C2 x e to the 3x. All right, done. All right. Now we've got problems, Houston. Look at that. One of our g of x's looks just like one of our complementary, or at least the same form. And what would be our typical response to that then? Make our particular solution. Well, let's go on and do those. So let's look at let's make this g1 of x. Actually, we'll do both of those as g1 of x. Okay? And this would be our g2 of x. Okay? So what's our y1, yp1? The particular solution for the first one. What would that be? A x squared plus, what do you say? Bx plus c. There's your first one. And your yp2. Okay, e. And then you can't use the e to the thing because you already got one. You can't use x times it, so we do x squared. So x squared e to the 3x. Okay, got it. Now we add these two together, and that gives you your y particular. So add that to that. So what are we going to do with that? Y sub p. That, when you add them together, that just becomes y sub p. Next thing we do is yp p prime. You have to take the derivative of it. And what would that be? Help me, help me. Help me. 2ax plus b plus 2ex e to the 3x plus 2ex squared. Wait, what was that? 6ex squared e to the 3x. Okay? Okay, wait just a second. I'm moving slowly. Oh, man. Okay, first we did, okay, e is times everything, so pull it. We do, you did the derivative of this times that, so that would be 2x e to the 3x. Now the e's still out there. And you got ex squared times the derivative of this. Well, the derivative of this is e to the 3x, chain rule times 3. So then the, oh wait. That 2 was from here. Well, okay, so that's 3. Sorry about that. Goodness gracious. It hurts to move. Okay, I was looking at the second one, not the first one. Okay. That's a 3. Okay. All right. I hope it's right now. All right, what do we do from that? I don't think there's anything we can do to simplify. So where do we go from here? And I don't know why I put a dash in front of that, but I'm going to take it out of the way because it looks like a minus sign. I think I was just emphasizing something there, but let me get those out of there so they won't be confusing. What do we do next? Help me. Got to get this one, right? Anybody? What do you do next? Okay, y double prime p. Okay, and what would that be? Anybody? It's not that hard. Second? 2a plus the b derivative, that goes away now. So what do you have next? A little louder. Say one more time. Okay. Are you asking something about that term? Yeah, that's a 3x up there. Is that what you meant? Yeah. Okay. So, say a little louder. I can't hear. I'm sorry. Okay, you got the 2 and the e are there. Okay, which are you taking the derivative of? First or second? Help me. Okay, it's the product rule, right? I brought the 2e out. Okay, that's just a constant. So if you do the derivative of that, that's 1 e to the 3x. So that's what goes next, just e to the 3x. Okay? But now we got to do the second one, which would have been a 2e. Okay? But you're going to have the x times the derivative of this. And what's the derivative of that? E to the 3x times 3. So that 2 will now become a 6. That's the one I was anticipating. So that's now a 6e e to the 3x. I hate capital E little e. Okay. No, the x is in there. Okay. 6ex plus 6ex e to the 3x. Okay? Now we got, sorry, got to do the product rule again, right? So what will that give you for that last term? Plus, help me. Somebody, help me, I'm struggling here. You tell me. We got a product. The 3e is out front, okay? You got a product here. How do you take the derivative of a product? Anybody? Say again?
How do you take the product rule?
Yeah.
It's the first term times the derivative of the second term.
Okay. First time derivative of the second. So that'll have an x squared in it. The derivative of this will be a
That's just e to the 3. What is it?
yeah, e to the 3x, then chain rule it 3e to the 3x.
Yes.
So that'll be a 3 times the 3e, so that'll be a 9. Okay. Have to hold this. 9e, and you did the first, so x squared e to the 3x. Now the second half of the product rule. Remember the 3x is there. And what's that? Doing this again. 3e is there. So what would that be?
E to the 3x times the derivative of
Which is derivative of x squared is 2x. Okay, so then that 2x will be 2 times 3. That'll be the 6. Okay, 6 e x e to the 3x. Right? Hope I got it. All right. Now let's put them together. Well, those are our derivatives. Now we plug those back into our original. So that's a 2a plus 2. Can I combine anything here? Nothing there. 2e e to the 3x. And here we have a 6x and a 6x. I think that comes out to be a 12 e x e to the 3x, and plus a 9 e x squared e to the 3x. So there's our y double prime. Whoa. Let's see about our minus 6 y prime. So it's minus 6 times 2, so that'll be a minus 12ax minus 6b minus 12e x e to the 3x and minus 18. Oh wait, yeah, e x squared e to the 3x. Okay, I'm doing minus 6 times this line. I hope I did it right. We've still got the y, and that's going to be plus 9 times x squared plus 9, that's 9ax squared, 9b x plus 9c plus 9e x squared e to the 3x. And that's supposed to equal 6x squared plus 2 minus 12e to the 3x. That's a lot of terms, isn't it? Okay. Let's see what we can do. Let's start with our x squared terms. Because you know that's got to be, the coefficient has to be 6. no x squared terms here, here, or here until you get right there. And that's the only x squared term. So we got 9a is equal to 6. What does that mean? Okay, 9a is equal to 6. A is equal to 2/3. Is that what you said? Okay, 2/3. All right, we've taken care of that one and that one. All right. Now let's go to our constant terms. Here we have a 2a minus 6b plus 9c. Okay? All right, but a is 2/3, so that will be 4/3 minus 6b plus 9c, and that has to equal 2. Okay? Now, I really don't like having fractions in there, so I'm going to multiply everything by 3, and that would produce 4 minus 18b plus 27c. I may not like that I did that. Is equal to 6. So let's change that to be 18b minus 27c is equal to minus 2. No special reason, I just don't like leading off with a negative. There's an equation. We can't solve it until we get another one with b and c. So let's continue. Okay, we've taken care of our constant here, our constant here, and our constant here, and that constant there. Now, the e to the 3x's, that's what we're going to deal with next, and that gives me, I'm running out of room. Okay, let's try it here. 2e, okay, e to the 3x's. Is that the only place? That is the only one I see. Say again?
Minus 12 e to the 3x. That's the other side.
Did you see one?
No,
Okay.
be equal to negative.
I think that may be it. That's equal to minus 12. Okay? I think we can figure that one, can't we? E is equal to negative 6. That doesn't help us there any, but it helps us there. So we got A, and we got E, and we got some combination of B and C. I still have more work to do. I need some room to work. So let's see what I can erase. Okay, I don't think I need this one anymore. And that one. And that one. I can get rid of those, I think. And I think, do I need my particular solution anymore? Yeah, I might. Yeah, I do. Okay, I don't think I need these anymore. I need my complementary. I don't think I need my derivative of the particular, or the second derivative of the particular, because I've combined them together. I hope I have correctly. Okay, I think that's all I can get rid of right now. Let's see. Okay. Yuck. Not coming up. Okay. Now we got it. So, let's do our x e to the 3x's. There we have 12 times a minus 6 is going to be a minus 72. Okay, minus 72. That'll take care of this term. X e to the 3x. And here we have a positive 72. Okay. Any more x to the 3x? None. Oh, and I took care of this one. Yeah, I've used that one already. So yeah, that adds to 0, which it should. Okay. We wanted those to disappear. So we didn't really need to plug in the e's. We just saw these two cancel out. So I don't need that one anymore, so I'll erase it. That's just taking up space. Okay. Now, 9ex squared e to the 3x minus 18ex squared e to the 3x plus 9ex squared. Yeah, those add to 0, so we don't need those anymore. Now let's look at our x terms. We have minus 12 times a. So that is minus 8, isn't it? Since a is 2/3 and minus 12 times 2/3 is minus 8, right? And here we have a b term plus 9b. Okay, and we don't have any x terms here, so this has to equal 0. So, not looking pretty, but it looks like b is equal to 8/9. Is that at all true? Where are we? 8/9, I believe we're right. Okay, and since b is equal to 8/9, this will be 18 times 8/9 would be 16, wouldn't it? 16 minus 27c is equal to -2. So let's make that 18 is equal to 27c. So c is equal to 2/3, right? If I did it right. C equal to, yes. So here c is equal to 2/3, b is equal to 8/9, a is equal to that, a, b, c, we didn't have a d, e, I think that's all. Yep, that's all. All right. Now this is not a initial condition problem, so we don't have to worry with that. I think we can write down our general solution now. Y is equal to c1 e to the 3x plus c2 x e to the 3x plus your a was 2/3 x squared, your b was plus 8/9 x, your c was plus 2/3. Really? A and C were the same? Yep. Okay. Where was I? Okay. Plus, and our E was -6, that's a -6 x squared e to the 3x. That's all we can do on that one, I think. So y is equal to c1 e to the 3x plus c2 x e to the 3x plus 2/3 x squared plus 8/9 x plus 2/3 minus 6 x squared e to the x. Good for them. All right. We've got what, 3 minutes left? 5 minutes left, something like that. Well, to go over the end of the activities, I think we almost have to stop now, don't we? Okay. That was too quick on an answer. Okay. All right. That's where we'll have to end it today. So let's talk about where we go from here. All right. I will, right now, if I can find it, give you the last test. And we didn't get far enough for everything to cover. So I'll tell you what we're going to cover and what not. Okay? Now let's see what we got covered and what we didn't. Number one, the independent, dependent, we covered that way back in 4.1 or 4.2. So you can answer those. Okay? Number two, all we did was undetermined coefficients. We didn't get far enough to do variation of parameters. So for A through F under number two, just the first blank there that you can do. You could either put a yes or a no. It says choose the input function g of x for which the method of undetermined coefficients is applicable, and don't worry about the variation of parameters. We didn't get that far. So therefore, is that g of x appropriate for applicable for undetermined coefficients? Okay, so the kind of stuff we were just doing. You just put y or n, yes or no. You put yes or no, you got room enough. Just don't worry about the variation of parameters. Okay, and then the last three problems, 3, 4, well, it says 3 through 6. There is no 6. Okay, 3 through 5, find the general solution of each differential equation. The first two of those are homogeneous, and the last one is non-homogeneous. So they'll be slightly different there. You might need more room to fill in, a longer blank right underneath it or above it, or figure out a way to do it right on another piece of paper. So basically, you'll have 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, and number 1, 1, 2, 3, 4, 5, 6 under number 2, and 3 at the bottom of the page. That's your last test. Hopefully it's short enough, it's not going to take you so awfully long to get it done. Okay, so let's talk about that part of it. Something doesn't feel right here. No, that's okay. All right. Now, I've given that to you. Here's the number one thing I want to say. I didn't want to forget this. I think I've asked you a few times before. If I didn't, I meant to. I've been asking for a couple weeks now, have you seen anything on student course evaluations? And so far in every class I've been told no, 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 until last Tuesday evening, this week. My evening class said, yeah, we just saw that. It just came out either last week or early this week. So the student course evaluations are open, okay? You should have seen it in an email if you get Lawson's email. Do you? Okay, did you see something on it? Okay. Okay, have you already done the student course evaluation? No. Please do those. Please do those. I value our Lawson, but I get those fall and spring. I especially value you non-Lawson students to see, I won't ever know who said what, so don't worry about that, but I want to see what y'all feel about the course, because see if what I need to do to make it better, okay? So, please do the student course evaluation. All I see is the composite. There's no way I can identify who says what, so be very honest, okay? Yeah, very honest with that. Okay, so please do the student course evaluation. I know they'll be open through finals, so it'll be through next week and probably into the following week, but I don't know how late they'll keep those open. So please do those before you forget it. Okay, so there's that. All right, now how about turning in your test? Okay, the one you just got. Now, I don't know, I didn't keep up with who's turning in papers or not. Hopefully all of you got your papers in, okay, and got your other test in. But if not, get those to me, okay? So when do you turn in whatever you're missing now? I know the last test. Well, I'll be on this campus. I don't think you're going to finish it today, but I'll be on this campus. I got a class right after this, 10 till 11:50. I have another class at 12, and it technically goes till 3:30. But it's not going to go that late today because there's no lab today. So no, we'll miss the last part. All they've got to do is take their last chapter test. I'd hoped to go on a field trip today, but so far I haven't heard from the guy that we could do it. So we may not be able to go on the field trip. So I should be in the office, unless I'm on the field trip, I should be in the office, from, I would say, 1 o'clock until 3:30, okay? But if I'm on the field trip, I won't be on campus at all, okay? Then, at 3:30, I'll leave to go to the Birmingham East Campus, and I'll be there. Now, if any of you, if Birmingham East Campus is an easier place for you to turn in your work, I'm there on Tuesday and Thursday afternoons from 4 to 6. Today I'm teaching in class, so if you do come, try to make it between 5:30 and 6, because I'm teaching from 4 to 5:30. But next week, Tuesday and Thursday, I'm there 4 to 6, so if that's convenient for you, you can turn in stuff there. Okay, now do all of you know where my office is? I didn't ask that.
Room 265.
265, you know where that is? Everybody? Okay, good. All right, well, I won't point it out to you. Okay, basically, go that way almost until you hit the end of the wall. Come back a little bit and it's on the left. Okay, now let me give you my hours there. Okay, today I'm on this campus until 3:30, over there until 6. Monday of next week, I do have classes. Monday and Wednesday classes still happen on Monday. So I'll be in here teaching from 8 till 10:40, and then from 11 until 1:40. I'm usually still up here until at least 2 o'clock because I've got all sorts of things to do on the computer while I'm here. And then after that, I'm free as normal, from 2 to 6. I'll be down in my office somewhere close to that. Okay, let's talk about Tuesday of next week. Those two classes, the morning classes, have take-home tests. You're one of them, and the other one take-home tests as well. So I'll be in my office from 7:45 in the morning until noon. At noon, we have the final exam in this class, okay, in this room. And that will be from, basically, it's not going to take them more than, it's going to be very short. Well, let's give them from 12 to 2. Let's just say, if I'm not here at 2, check my office, okay? And then from 2 to 3:30, I'll be in my office. 3:30, I drive to Birmingham East. I'll be there from 4 to 6. No class then. You can come in anytime. Wednesday, completely free. I'm here on this campus, 7:45 in the morning until 6 o'clock at night. Okay? Thursday, completely free. In my office, 7:45. And no, I'm not going to stay in my office all that long. I'll be going to the restroom, going to here and there, and turning in this, that, and the other thing. So, but generally around my office from 7:45 in the morning until 3:30, because at 3:30 on Thursday, I go back to the Birmingham East Campus in case any of those are going to turn in work, and I'll be there from 4 to 6. Okay? Friday, the school is still closed. Even though that's August, the college is still closed on Friday. Now, please get me any work you still have outstanding, get it to me sometime next week. Today, if you can get it to me, but probably next week, any day, Monday through Thursday. Grades are due from us at noon on Monday. That means I cannot accept a lot of work coming in at 11:30. I'm not going to get the grades in by noon. So you're going to get it incomplete in that case. Then you get me the stuff, I'll get it graded and change the incomplete to a grade. Please don't, let's not go there. It's so much easier to get it in next week, Monday through Thursday. Now, if I happen not to be in the office when you come to turn something in, like I'm on the Birmingham East Campus or just not there, you can slide it under my door and I'll pick it up. Even if that's Thursday evening, when I've already gone to the Birmingham campus, slide it under my door. When I come in Monday morning, I can get it graded then and get the grades in. Okay? So I'd rather you not have a stack this big under my door on Monday morning, so try to get it in Monday through Thursday. Okay? Any questions? Please do the student course evaluation. I'm looking forward to seeing what these classes that have mostly transient students, how you evaluate the course. I really do care. I want to know. Good deal. Thanks. Been a good class. Enjoyed having you, getting to meet you, and good luck in your back at your schools. All right. Yes, ma'am.
You got an update on the old test?
In Blackboard? Yeah, I haven't. I just got it graded last night. I haven't gotten to Blackboard yet. Yeah, I'll change that.
What's your email?
My email, cfowler@bostonstate.edu. Good deal. Enjoyed having y'all in class. Let me